Good morning, ma'am. Myself, Omonika. I am from EC second year, second semester. Bearing pin number 244G580407. My topic name is Infinite Transmission Line in Theory and Analysis. Subject name EM Waves and Transmission Line. Subject code 23ECE407. Introduction to Infinite Transmission Line. Infinite transmission line are theoretical models used in electronic engineering. They helped simplifying the analysis of long transmission line by assuming they extended infinitely. This assumption allows engineers to drive key parameters without boundaries. Basic components. An infinite transmission line is characterized by its distributed parameters, transition, resistance, inductance, capacitance, and conductance. These are the characterized distributed parameters. These parameters are uniformly distributed along the length of the line. This line is analyzed using different equations to understand wave propagation. Wave propagation in transmission line. Transmission line can support voltage and current waves that propagates along their length. The wave equation describes how these waves behave in response to the line distribution parameters. Both forward and reverse traveling waves are considered in the analysis. Characteristic impedance Z0, that is integrated with Z0, is a key parameter that describes the relationship between voltage and current on the line. It is determined by the line's inductance and capacitance per unit area. For an infinite transmission line, Z0 remains constant regardless of the length of the line. Reflection coefficient. The reflection coefficient or point is the propagation of the wave that reflects back at the discontinuity. For the infinite transmission line, the effective of the reflection can be analyzed as the line where transmission in its characteristic impedance. This leads to minimal reflection, simplifying the analysis of signal integrity. Input impedance of infinite lines. The input impedance of an infinite transmission line can be derived by using the characteristic impedance and reflection coefficient. When properly terminated, the input impedance appears purely resistive and equal to the Z0, that is input impedance. The behave helps in design circuits that minimize losses and optimize performance. Lossless versus lossy lines. Lossless line, assuming zero resistance and conductance, simplifying analysis. Lossy lines account for resistive and dielectric losses, complicating the calculations. Each type has distinct implications for signal integrity and transmission efficiency. This is the lossless versus lossless. Lossless line can assume zero resistance and conductivity. For simplifying purpose, lossless account for resistive and dielectric losses in complicating the calculations. Each type has distinct implications for signal integrity and transmission efficiency. Applications of infinite transmission line. Infinite transmission lines are used in various applications including RF and microwave engineering. These are the frequencies: radio frequencies and microwave frequencies. They serve as models for the understanding antennas, filters, and other high frequency components. Infinite transmissions are widely used in antennas, filters, and other high frequencies components. Their theoretical nature allows for designing of real world systems with predictable behaviors. Limitation and practical consideration. The assumptions of infinite length is an idealization and does not hold for all scenarios. Real transmission lines have infinite length, which can introduction, reflection, and lossless. Engineering must account for these factors in practical design to ensure the performance meets specifications. These are the limitations and practical consideration. What are they? The assumption of infinite length is an idealization and does not hold for all scenarios. Real-time transmission lines are infinite length, which can introduction, reflection, and lossless. Conclusion: Infinite transmission line provides a foundational understanding of wave propagation in electrical system. Their critical frames aids in the design and analysis of various electronic components. Ongoing advancement in technology continue to enhance the relevance of this theory is modern applications. This is the conclusion. Infinite transmission line provides a fundamental understanding of wave propagation in electrical system. Thank you.